Thanks, Papu, and thanks, everyone. Good morning. My name's Andrew Young. I'm the Knowledge Director at the GovLab, and I have the pleasure to introduce our first set of research flash presentations. So I'm going to invite each of the speakers up to have a seat, and then we'll go one by one through the presentations, and then leave some time at the end for some audience Q&A. So the three speakers that we have lined up for this first session are Riddhi Kashyap, an associate professor of social demography at Nuffield College, University of Oxford. So Riddhi, if you could, thank you. And then Mohammed Raza Khan of UC Berkeley. And finally, Claudio Bosco, a senior research associate at the Flowminder Foundation. So these are all presentations on research that was introduced briefly by Bapu in the last round. Have a chance to hear about them in a little bit more detail, one by one, and then again we'll have time for audience Q&A at the end. So, Riddhi, do you want to get us started? Thank you so much.
Is someone keeping a check of the time? Academics have a bad reputation. So, hello, my name is Riddhi Kashyap. I'm from the University of Oxford, and I'm very excited to be here, to be a part of this community, and take the discussion forward today on how we can use different kinds of big data sources to study the lives of women and girls. And today I'm going to present our research that we've been doing as a part of our Data2X project on using one particular source of big data, which is ad audience estimates. I'll describe this in this talk, and how we can use this data source to measure global digital gender inequalities. Right. I want to start out by saying that this is, of course, a team effort, and I'm here representing an interdisciplinary group of both computer scientists and social scientists spanning the University of Oxford and the Qatar Computing Research Institute. Ingmar and Reham are here today, so make sure you also meet them and ask them about the work we're doing. Right. So I want to start out by talking about the fact that in the last 2 decades, essentially, we've witnessed a digital revolution, an unprecedented expansion of internet and mobile phone technologies. And of course, this is a technological revolution, but it's also a social revolution in the sense that the internet and mobile phones have the potential to empower marginalized populations and really enhance our progress towards the attainment of the Sustainable Development Goals. And several of the SDGs actually acknowledge the role of ICTs in digital technologies, and one of the SDGs that does this explicitly is SDG Goal 5 on gender equality, which pledges to enhance the use of information and communication technology to promote the empowerment of women. So this is a development goal that is put forward in SDG 5, but despite this goal being put forward, there's significant concerns that there is gender inequality in access to the internet and technologies. And the ITU, the UN specialized agency for telecommunications, estimates that some 200 million fewer women are online compared with men. But our ability to track progress on digital gender inequalities is actually considerably limited because of a gender data gap, right? We're here to discuss gender data gaps, and gender access to technology and internet use and mobile phone use by gender of the user is actually something that through traditional data sources we know considerably little about. So when we do have these survey data sources, they're often not available for a number of countries, and there's irregular production. There's also inconsistency in the way these things can be measured that impede cross-national comparison. So to illustrate this here, you see a map in which we've tried to compute gender gaps in internet use using survey data that is available through the ITU, but collected through national statistical agencies in different countries. And what this map shows you is that there are large parts of South Asia and Sub-Saharan Africa where we don't have survey data to be able to compute this indicator. This similarly here is mobile phone ownership gender gaps. And this is again a female to male ratio, so a higher value would represent equality, gender equality, and lower values represent gender inequality. And here as well, we have better coverage than with the internet use gender gaps indicator, but we still see that, especially in sub-Saharan Africa, in traditional data sources, we have a sizable gender data gap, right? So of course, the digital revolution, as I said, is a social revolution. It has the potential to empower marginalized populations, but of course the digital revolution is also a data revolution. It enables new kinds of data sources that potentially help us to fill some of these gender data gaps, and that's what our work has been doing. And in particular, the data source that we've been using, the digital data source that we've been using, is ad audience estimates. So what are ad audience estimates? All large-scale online platforms essentially make their money, as we all know, through advertising. And ad audience estimates are essentially estimates of the audience sizes of different online platforms that are provided to potential advertisers on these platforms. So these are aggregate data, they're anonymous, and they're, before you launch an ad, free of cost. Of course, when you launch an ad, you have to pay for it. But before you launch it, they're available generally free of cost. And they allow us to answer a kind of question, which is how many users of X characteristics, perhaps gender, location, age, device type, are on these particular platforms, right? So in this sense, I'm a demographer. They act as a kind of digital census of the online platforms, right? So not of the population at large, but of the population of these particular platforms. So here's Facebook's advertising platform on the front end, and we've, as a part of our project, been using this quite a lot for our analysis. And the ad audience estimates here, so here on Facebook's ad platforms, I've run a query to say how many Facebook users are there who are men over the age of 18 in Nigeria, right? And the number here is 15 million on the right. You see, that's sort of an estimate of Facebook users in Nigeria who are men. You can run the same query, how many Facebook users are women in Nigeria? And that tells you that there's 9.1 million, right? So quite simply, what we do is we run these kinds of queries, and we're able to generate what we call a Facebook gender gap index, which is simply the ratio, the female to male ratio of users on Facebook. Now, we're interested in digital gender inequality and not demographic gender imbalances. So, for example, in Qatar, there are a lot more men in the population because of migration flows and labor migration flows. And just because we would observe, so if we observed a lot of men in the Qatari population online, that wouldn't be digital inequality, but it would just be that there are many more men in the Qatari population. So we divide this female to male ratio of users on Facebook by female to male ratios of the population, right? So sort of a demographic ratio. And we get this Facebook gender gap index. It's quite a straightforward index. It's just a ratio. And it allows us to capture digital gender inequality. But we're interested in seeing to what extent women not being online on Facebook is actually capturing internet access gender inequalities or mobile ownership gender inequalities. So we try and validate this against survey-based measures. So using survey-based data, we compute an internet gender gap index, which is simply the proportion of the female population that's on the internet and the proportion of the male population that's on the internet. And we can compute something similar, mobile gender gap index, using survey data. So while this is a measure of Facebook users, not internet users per se, by gender, we find that actually they're highly correlated, the two indicators. In excess of 0.8, we find these correlations. For mobile phone gender gap index as well, we find that the correlation is about 0.75 between Facebook-based measures and the survey-based measures. So seeing that there's this strong correlation, so when women are not online on Facebook, it's a sign in these countries they're also not online altogether. Drawing from that insight, we then sort of fit three types of predictive models, where we take these Facebook indicators and we try and predict the internet gender gap index that we get from survey-based sources. And here we take in this online model just simply the Facebook global 18 plus users ratio, and we use that to predict the internet access gender gap or the mobile phone gender gap. And we compare this against two other models. The offline model assumes that we don't have any Facebook or online data, but we have just offline variables related to a country's level of development and so on, right? So what if we didn't have any digital data? And online, offline, in which we combine development indicators with the Facebook data that we have, the Facebook indicators, to predict the Internet Gender Gap Index. And this is what this map looks like when we use the Facebook Gender Gap Index to essentially expand global coverage of the Internet Gender Gap Index. So those parts of Sub-Saharan Africa where we don't have this data available, with Facebook we can dramatically increase geographical coverage. In general, we find that our online models drawing on Facebook data outperform simple offline models which don't rely on any digital trace data from Facebook. So we can dramatically expand geographical coverage, and on our website, digitalgendergaps.org, we provide daily updates. So this is something that Bapu was talking about. We have higher temporal resolution with this. We just query the Facebook marketing API regularly to be able to predict internet access gender gaps. But we actually find that our best performing models are those that combine online data with offline indicators, such as those related to GDP as well as gender gaps in tertiary education. I should note here that there are a number of limitations as well in this, in that we have insufficient data at the moment to be able to assess our model performance over time, because we don't have overlap of survey data as well as Facebook data for all of these periods. And in the end, we are also essentially taking data that are coming from black box algorithms. So there's no way for us to audit data quality. I have the last few minutes, and I just want to say we've also been expanding by trying to use Google AdWords. And here in AdWords, we get impressions estimates, not audience estimates. So we don't get monthly active users, but we get estimates of how many times an ad might be seen by a set of eyes. And using these impressions, we can also compute female to male ratios of impressions gender gaps, as opposed to user gaps from Facebook. In general, we find that with Google, with the Google AdWords, gender gaps actually show greater gender inequality than those from Facebook, which perhaps might be related to the type of measure that we have, impressions versus users, but this is an area that we're expanding. So we see in general that in Sub-Saharan Africa and in South Asia, there are sizable gender inequalities in digital access, in internet access, and this is what both Google and Facebook are showing us. And these are really proxies for low-level digital skills, is what our work has also been finding. So essentially, we're capturing use, but low-level digital skills is the type of use that perhaps we're capturing. So just to conclude, what our work is showing is that these are good complementary data sources. They don't replace survey data sets. We're always validating against them, trying to predict them using these online indicators. But they're also providing a different kind of measure, right? And I think moving forward, we really need to see and monitor our predictive performance over time. We have to bear in mind that we have a number of data access limitations. For example, we can't go back in time. We can only move forward in time with collecting Facebook data, which limits the kinds of things that we're able to do. And our work has opened up really a range of exciting questions. For example, how do men and women use digital technologies such as the internet and mobile phones? How do we understand and explain variation in digital gender gaps? And this kind of system that we've tried to build on digitalgendergaps.org could really help us analyze the effect of, say, policy interventions or specific kinds of changes to see how digital gender gaps change over time. So we're very excited to move forward in this direction and try and use this web system that we've built to analyze these changes. Thank you also to Data2X for supporting this work.
Wonderful. Thank you so much. I'm sure there's already lots of questions brewing, but we're going to invite Mohammed to share a little bit about his work on educational inequality, and then we'll jump into the Q&A afterward.
Hi, everyone. Today I'm going to present one of the research projects that I did during my PhD at UC Berkeley School of Information on gender disparity analysis using mobile phone metadata. So this is going to be the scheme of my presentation today. So the basic motivation of this work was to see that to what extent the gender disparities that we see in the real world are manifested in the social networks data of the developing countries. And when we talk about analysis of gender disparities data using the social networks data, there are two major issues that we need to handle. The first one is the availability of population scale social networks data. the data set should be comprehensive enough to represent different parts of the population. And the second issue is that how we can actually calculate the ground truth about gender disparity. So I'm going to briefly touch upon these issues, that how we were able to resolve these issues in our research. So just for background, when we talk about data sources for human behavior analysis, so most of the time Facebook, Twitter, and WhatsApp like data sources comes to our mind. Some additional data sources like satellites, sensors, or mobile phones are also popular, but most of the time researchers use Facebook, Twitter, or WhatsApp related data sets. But there is a primary problem with these data sources, that most of them are dependent upon the availability of the internet or access to internet for the individuals. So if we look at these two maps, so on my left side you can see the mobile phone connectivity, or the percentage of adult population which had access to mobile phones, and on the right hand side you can see the percentage of adult population in different parts of the world, the percentage which had access to internet. And you can see that there is still a digital divide. And so you can see that in Africa, around 29% of the population had access to internet in January 2017, 29% of the adult population. And in Africa, around 81% of the adult population had access to mobile phones. And this thing has been improving. So as a result of this, the mobile phones have been used in different type of research projects, and we see it as an increasing trend. And some examples of using mobile phone in analysis of human behavior data include predicting poverty and wealth, analyzing racial attributes of individuals, and analyzing human mobility. So what I wanted to describe in these slides was that CDR data can be a good data source because it is comprehensive enough. It is relatively easy to collect, provided you have good relations with the telco operators or government organizations. So this resolves our first problem that we were talking about, that is the availability of population scale social networks data. The second problem still remains, that what about the ground truth about gender parity? How we are still reliant on different type of surveys over there. So luckily we had some CDR data from Pakistan, and then there was an NGO in Pakistan which was collecting educational enrollment data in different districts of Pakistan. And the basic aim of that NGO was to convince different politicians to invest more in the education. So they also calculated different type of metrics around educational enrollment of females and males at different levels in different districts. So we decided to use that data set as our ground truth. And to be precise, we were using the ratio of female enrollment to male enrollment at the primary school levels as the ground truth proxy of gender disparity in different districts of Pakistan. So this is a brief overview of the data that we were using in this research. So we had a data of around 7 days, which comprised more than 1 billion calls and SMS data set. And in this data, around 5.5 million users were male users and around 500,000 users were female. And we were able to annotate male and female users because the national IDs in Pakistan for males are slightly different for the national IDs for females. So we were able to get this information whether this particular account belongs to a male or female users, but still there can be some problems when the head of the household is going to register the account on his name, but it is going to be used by other people in the family. Some other important things that I want to highlight in this slide is that if you see at the second and third map, so you can see that most of, so the districts in the northeastern part of Pakistan have got higher educational gender parity and at the same time higher population density as well. But districts on the southwest side, this part specifically, so these are very remote areas and it is very hard to do extensive surveys over there. So I'm going to come back to it, that how our models can help over there to get some proxy measures about educational gender disparity in these districts which are very remote, where it is not very easy to conduct extensive surveys. So we had two basic research questions in mind. First of all, we wanted to analyze different aspects of social networks of men and women as represented in these mobile communication metadata sets. And then we wanted to see whether we can use these differences to develop a machine learning model to predict educational gender disparity. So for the first research question, there has been a lot of research on analysis of different segments of the society. So we decided to use some of the aspects like network activity. By network activity, I mean that how many calls and SMS are being made by males and female users on the average. Similarly, we also analyze some of the metrics or some of the aspects related to network status, network formation, network diversity, and some mobility related measures as well. In interest of time, I'm going to describe some of the interesting aspects that we analyzed, but we did some extensive analysis and we were able to identify quite a few statistical significant variables. But let's look at some of the interesting aspects that we were able to analyze. So first of all, if we look at the network activity, we see that females on the average are sending more, are making more calls and sending more SMS on the average as compared to men. This is interesting because at first we were expecting that maybe females are going to be having less number of calls and SMS on the average. But on the other hand, if we talk about size of the network, which is represented by the last row, degree centrality in this table on the slide, so we see that males have still got a bigger network. So this was an interesting pattern that we observed, and it can stem from, there can be multiple explanations for it. One possible explanation is that males were so there were 5.5 million users, male users in our data set, whereas there were only 0.5 million female users in the data set. And then males are the dominant part of the workforce in Pakistan. So they are expected to have much bigger network as compared to females. Another thing, we also wanted to see that what about the network of different nodes or different individuals. So this is represented by the term embeddedness over here. And in short, embeddedness is telling us that whether the networks or whether the people who are connected to one individuals are also connected to each other or not. And here we see that females are having much more interconnected network. And one possible explanation of this is that as most of the females are going to be communicating with other relatives, and those relatives may also be connected with each other. So it is according to the social norms in Pakistan. So we also observed some other things that like homophily and diversity related measures. By homophily, we wanted to see that whether males are more interested in forming networks with males and vice versa for females. And we see that the homophily for males is higher as compared to females. But there is one problem with the homophily measures, that it doesn't take into account the number of calls being made to each person in the network. So that is being accommodated by the diversity related measures. And we see that the diversity for females is higher as compared to, gender diversity for females is higher as compared to gender diversity for males, but location diversity for males is slightly higher as compared to gender diversity for females. So just to conclude, we can see that men have got bigger network size and higher location diversity, which confirms social norms. Women's connections are much more highly connected with each other, and then higher gender homophily for men. I'm going to come back to some of the conclusions, but our second research question was that whether we can use these aspects or these things that we analyze in the network to develop a predictive model that can help predict educational gender disparity in different districts of Pakistan. To this end, we took all of the ego node individual features and we calculated some aggregate features. By aggregate features, I mean that we converted the individual features into district level features, and then we ranked the features according to their explanatory power, which is these were the top two features that we found were having the highest R-squares, and so they had the highest explanatory power. So on the basis of it, we conducted 2 different experiments, or we developed 2 different machine learning models. In the first one, we tried to predict raw district level gender parity score. And over here, you can see that our model that is shown using the blue bar is able to outperform the other models. So in terms of R-square score. So the baseline 1 over here is when we only use the network activity. Baseline 2 is that we only use the network size of males and females in our model, or in other words, ratio of network size of females and males as the primary feature. And then the baseline 3 is combination of baseline 1 and baseline 2. So we can see that as compared to these baselines, our model is performing very well. And similarly, we turned our experiment into a classification experiment where we aggregated the raw gender disparity scores into low, medium, and high categories, because in gender disparity, it is much more important to get an idea about whether the gender disparity for a district is high or low as compared to having the raw score. And over here, we can see that using the same baseline measures, our model is still outperforming the other baseline models. So just to conclude, gender annotated data sets can be a good data set for this type of research where we are trying to analyze population level gender disparities. But still, there are some interesting aspects that need further exploration, and some of that references are mentioned over here. I would just like to say that although that CDR data sets can be quite comprehensive, but they are still not immune to some of the biases that we were discussing in the earlier discussions. So that is it from my side, and thanks to Data2X Foundation and especially Bapu for all his feedback. Thank you.
Thanks so much, Mohammed. Claudio?
Good morning to everyone. My name is Claudio Bosco. I'm Senior Research Associate by the Flowminder Foundation. Today I will talk about the project we have done in collaboration with the University of Southampton and Ansel, that is one of the largest Nepalese mobile phone company. Before starting to talk about the project, just a couple of words who is Flowminder. Flowminder is a Swedish non-profit foundation that pioneered in the use of mobile phone data for humanitarian and development field. The core principles of Flowminder are mainly 3 that we can summarize in open methods, open code, open data, that are used for try to close the data deficit for vulnerable populations. We mainly work in the integration of traditional and novel data types. So we are talking about like geolocated house survey mixed with remote sensing, GIS layers, and the use of mobile phone data. Going to the project that we have done with 2X. 2 were the main objective of this project. The first was to exploit the spatial temporal data collected by a mobile phone company to improve the understanding of dynamics in Nepal. Fundamentally, we tried to split the mobile phone database of Ansel in male and female and see how people move in Nepal. The second main objective of this project was to explore the feasibility of producing a high-resolution map. We are talking about a resolution around 1 kilometer of a different set of gender disaggregated indicators. Also, for doing this part of the project, we exploited the use of mobile phone data. Before starting to enter into detail, a couple of words on our secure end-to-end analytic process. So sensitivity of the data is an important problem. What I want to say is that never Flowminder get access to raw data. All the raw data are de-identified through the use of tokens by the mobile phone company. What we do is we can access on the server this data and do all the analysis on the server of the mobile phone company. The only things that can go out is our anonymized aggregated indicators and analysis that can go out of the server at the end of all the analysis, but after approval that Bappu and Elizabeth know very well from the mobile phone company. So we have to wait until we don't receive the formal approval that also the aggregated data are okay for the company. For reaching our objective to split the gender, analyze the dynamics in the country, we performed a mobile phone survey with two main objectives. The first was to validate the database of NCEL because they collect information about gender. And the second was to check the SIM sharing to see if really we had a one-to-one link with CDR data. The mobile phone survey was done initially with more than 5,000 users involved. And we recontacted 20% of this for validation. Because of some uncertainty that we had on SIM sharing, we have done another survey on 1/4 of the sample, so a little bit more than 1,200 people that were recontacted again with different questions. And during this part of the work, we also used a third-party software and independent coordinator to check that everything was perfect. This is the geographical distribution of the survey respondent in the country. The main results we found after this work is that there is a huge SIM sharing rate in Nepal. Almost 50% of the people, even if they own a SIM, they share the SIM. Up to 7 people use the same SIM. The majority are within the family context, relatives, parents, sisters. The real problem we had in trying to gender disaggregate the database is that more than 35% of the SIM sharing is mixed gender. So we have no idea how much time a male or a female use this phone, 50-50, 10, 90, 99, 1, we have no idea. The main findings of this part of the project is that SIM sharing is a problem. It's quite common in Nepal, and this can create problems in trying to identify the gender. So what we have done was to remove the SIM sharing, and our performance, our modeling performance, are perfectly in line with the results of many publications you can find in the literature. Reintroducing SIM sharing, even we used a neural network, any kind of machine learning techniques, we were not able to find the key to put some order in this noise. We also tried to advanced techniques, but trying to maximize the entropy, the distribution that maximized the entropy, but anyway was not possible. So the rate of SIM sharing is so high that for our models was very, very difficult to understand something here. So at the end, because of this SIM sharing, it was not possible to split by gender the database of the mobile phone company. So this is the main result. So we understood that even if in the literature no one mentioned this problem, this is something that exists and needs to be considered. The second part of the project is linked with higher resolution, the creation of higher resolution map at 1 kilometer resolution of gender disaggregated vulnerability indicators. Just a quick look at the techniques we use. What we do, we start with observation. In this case, we use the DHS data on different indicators like literacy or the birth at health facilities. We explored the correlation with many different covariates, layers at high spatial resolution, and we exploit Bayesian geospatial model or machine learning techniques to create a resolution map that covered the whole country, also in areas where we didn't have any data. These are examples of the layer that we exploit to find this correlation, like nighttime lights or distance from roads. In this part of the project, as I mentioned before, we use also CDR data. Because CDR data are totally different, we are talking about data at tower level, aggregated at tower level. We pass from this tower level, exploiting the Voronoi polygon, to the same resolution of all the other layers that are a grid of 1 kilometer square. A word more, I would like to say something more about why we are working at high spatial resolution. So 1 kilometer resolution is very high. Normally, the decision maker and policymaker doesn't work at this resolution. The added value is that starting from this very high resolution, it's possible to reaggregate the data at any kind of level. So here you can see an example of a map aggregated at the level of local region. What happened in Nepal in the 2 years I worked in this project is that the government decided to change all the administrative levels. For us, it was just enough to aggregate the data with the new administrative level. I started with district, I finished with local regions. The indicators that we explored in Nepal were male and female literacy, male and female agriculture-based occupation, and births in health facilities. Both, as mentioned before, exploiting Bayesian geostatistical model and neural networks. Here are a few examples of the maps we produced. This is, for example, the high-resolution version of the female literacy. The explained variance of this model is pretty high, 65% in validation. You can see also the associated uncertainty, because for any map that we create, we also create a map of uncertainty. That is pretty low all over the country, with the exception of the northeast of the country. In these maps, you can see a graph that results from the comparison between the DHS data that are available at province level and our models. As you can see, our results aggregated at province level are perfectly in line with DHS data. You can see also that the addition of CDR data doesn't improve a lot the models, but it's interesting to see that, for example, in province 2, the use of CDR data was able to correct some discrepancy that happened at local level. So we see an added value of exploiting also this source of data. Again, a few examples of other maps we created. This is the births at health facility. And this map is the female agriculture-based occupation. I conclude just with the main findings. After this 2 years project, we know that regarding this part of the project, it's possible to create sufficiently accurate maps that are relevant for policymakers. We also know that there are problems, for example, for males. I showed you only a map of female because we didn't have the same results for males. We explored this with a local expert, and it looks like at the basis there are social and cultural factors. So, for example, for literacy, talking with experts, they mentioned the fact that there is a lot of pressure on males for going abroad and bring money home. It's something that doesn't happen with women. And this is something that is difficult to detect. So for overpassing these problems in future, probably will be necessary to add socio-economical covariates to our work. Thank you for your attention.
Thank you so much, Claudio. So we have about 10 minutes left, so I have no shortage of questions, but I think let's just jump into the audience Q&A. If anyone has a question, please raise your hand. So we have mics coming around, I believe. So right there. And if you could say your name and affiliation, and also in the spirit of the 100 Questions Initiative, questions that end in a question mark, very much appreciated.
I'll try. Marlene Lee, the Population Reference Bureau. And this is a question for all the panel members. I think it got answered to varying degrees in the presentations. But in terms of the data you're using, how do you really see unique users or unique monthly users? Because if I take my example, some months I have 2 cell phones, and some months one of my cell phones is my mother's. And then there's a question specific to the first presentation, which is in terms of the predictive model filling in the gaps in data for Africa. Are there any concerns that you're filling in for geographies that may be very different than the geographies where you actually have data that socially and culturally and historically may be very different? Thank you.
Who wants to jump in?
Should I? Can you hear me? Yeah. Thanks for your question. I'm going to start off by answering the first one, which is, can we identify unique users? We are dealing in our work sort of with aggregates, so we just see how aggregates change over time. So we don't have any unique users, or we don't really have a way to be able to tell how unique users, who the unique users are, and how that changes over time. But to your second question, your point is well taken. So the idea here is that we're essentially looking at a relationship between the Facebook Gender Gap Index and the Internet Gender Gap Index. And of course, yes, we're making the assumption that that relationship, the model that we're predicting also applies in the same way to the countries where we don't have this data available. And so we do, of course, for a handful of sub-Saharan Africa, we do have some data available. And so, and we do reasonably well at predicting in those countries. So, we think that this could be a reasonable assumption. But actually, it's something that moving forward, we really would like to be able to test and explore more. As more ground truth data become available, we'd like to be able to see when and where and how our model performance changes over time.
So in our case, we excluded the users that were having more than one account registered on their name. But in short, I will say that this is a tricky problem to handle, and there is no single or simple way to handle this problem.
On our side, as I mentioned in my presentation, we checked 3 times that there was a single user on the other side, but of course, this doesn't mean that 100% sure that is the only user. Maybe we were just lucky to find the same person 3 times. Unfortunately, I really think that with this type of data, it is impossible to be totally sure. What is possible to do if the signal is affected by a noise that is not huge, like the SIM sharing I showed you, it's possible to use statistical techniques to try to manage this. But when you overpass a threshold, that is really a challenge.
Great. Other questions? In the back there? Oh.
Thank you. My name is Gerda Binder. I'm with UNICEF. And we are also particularly interested in having more insights into the digital divide as it concerns under 18-year-olds. And so my question to you is, because I assume you include the younger cohorts in your data and analysis, if you do an age aggregate out, do you actually have different findings and insights? Because there is so little we have data on that cohort and the understanding what is happening with that age group.
If I can answer, so regarding the data I used, there is a limit age, so we are not talking about children, so we are talking about people over 16 years, also for privacy reasons. So it was not possible to perform this mobile pulse survey on children. So you have to do these things on a population that is over 16 years, also because of the local law that exists in Nepal and we have to respect. So it's particularly difficult to reach children exploiting this type of data. Is an additional challenge.
So we haven't explicitly been looking at sort of the younger cohorts and the younger age groups, although in principle we do have data for ages under, above 13 until 18. So I can't give you a specific answer. A very general answer would be the data we do have aggregate user numbers by gender of the user for some of the younger age groups. But at the same time, and the general pattern we see is that amongst younger cohorts relative to older cohorts, there's greater gender equality, very generally speaking. But beyond that, I can't give you more. But we should have a discussion about it afterwards.
In our case, we were restricted by this fact that mobile phone users can only be registered to a person if he is 18 and above. So that level of representation was not there in our data set. And I would say that this is a good research topic. I have only seen some research papers around it. So this is a topic for further exploration.
Great. There's a question in the back there.
Thank you. Lawrence Noy with Open Data Watch. My question is mainly about the access to the data you're using. The first presenter talked about access to Facebook and Google ad platforms. How do you think about the sustainability of sort of continued research with a platform like that kind of depends on those companies continuing to be open with their data like that? And similarly, on the researchers using mobile phone records, again, how do you see kind of the long-term sustainability of relationships with companies like that kind of offer you this data source for your research? Thank you.
Wants to dive in on that easy one.
So I certainly hope they're sustainable. So if anyone here has some control over that, please keep them sustainable and make them more accessible. That would be fantastic. So I think, I mean, obviously, with a lot of these kinds of data sources, access and is an issue, and also there's also layers of access, right? So we're using the marketing API, which is publicly accessible and available. So it's essentially data that's provided to advertisers that here is being repurposed for social research. And that's sort of the point we want to make, that this is valuable also for understanding, in our case, gender inequalities, and in contexts where other kinds of data sources might not be able to do that on a regular basis. So I think, so we're using data that is publicly accessible through the marketing API and using it, and because advertising is an important part of the business model, I certainly hope it remains accessible moving forward. But it is something that we would I think we need to have a broader discussion about as well. Is trying to see and leverage the value of these data sources in other kinds of ways. So I think it's a bigger conversation.
In our case. So we were able to get this data because this data was originally used in another project related to financial inclusion. So I can say that telcos in the developing world are interested in sharing the data, provided proper anonymization is done, some other steps are taken care of, and then they should be able to see some advantage for themselves as well. So financial inclusion was one field where our research group was able to provide some insights which helped them. We collaborated with World Bank as well, and we were able to improve the financial inclusion in some of the African countries by a margin of 30%. So I would say that the other side should be able to see some benefits of data sharing as well.
Yeah, also the company we work with, so more or less is the same. So They have objectives that now are the same, so they want to support sustainable development goals. In my experience, I work with many different companies, and it depends also from the company. So there are huge differences. There are people that are more worried about the sensitivity of this data than about the objectives. So there is not a general rules, and depend from the company, from their view, and the way they want to support research.
Great. So we have time for one more question, please. It's on its way.
Hi, Judy Deers from the Ford Foundation. I was really encouraged by the final remark by Bapu around issues of power. And I was assuming that we would then move into presentations where we talked about to whom are we accountable for this data and why are we collecting it. And I guess, for me, it's women's movements on the ground who are going to use this and who are disrupting things there. What are we doing to disrupt big data as it exists? And how can we be accountable to women's movements as we go forward with this? And use sort of a feminist intersectional lens in the collection itself.
Another easy one. Please.
That's a hard question because I think so to some extent we need to recognize that there are sort of a multiplicity of data sources out there that could be used to shine light on the experiences of women and girls that sort of already exist but aren't available for researchers and others, social parties who are interested in this, to analyze and document some of these things. So first, sort of broader data access and data sharing that allows us to illuminate some of the lived experiences of individuals, especially women and girls, is really valuable to this end. In our case, I think we really want to highlight in our work that there are significant digital gender inequalities in sub-Saharan Africa and South Asia. That is a form of inequality that we really want to bring also to the forefront of the discussion about sort of gender, both gender and big data, but just gender inequality as a whole. I think understanding women and girls where they're not online, right, is valuable also both from a sort of a social empowerment perspective, but it's also important from a big data perspective, because if we can't de-bias big data, if we don't know if women aren't even online or why they're not online, right? So we think this is an example of a case where there is a data system that can help us illuminate new layers of a problem, but also help us to potentially track it moving forward. Because if we have this data system in place, if there are policies that are being implemented, or the women's movement realizes this is an issue to take forward, right, we can also potentially track this changing with the system in place.
I don't have a direct answer to the question, but I will just comment that I am strong believer in this thing that first of all you need to measure something, or you need to prove that something is wrong or something is missing. And the parts of the world that we are talking about are the parts of the world where I belong to. Over there are a lot of issues related to females' education and other stuff. So the ground truth data that we were using, I really like that NGO because they started a national level campaign in Pakistan, and they were trying to convince politicians to have this thing in their manifestos, that they should have more power or more resources allocated. They should promise that they are going to allocate more resources for females' education in general, and then females' education as well. So I would just say that it is more a passive role for these data systems right now. They can help convince people, they can help bring up some argument, but that is my comment.
Yeah, in addition to this, I can say that working in Nepal, what I understood is that often they haven't access to this type of information for remote areas. So the level of literacy in some Nepalese very remote areas is something that even the government have difficulty in knowing in details. So what I think is that the work we are trying to do is a support for women to understand what's the real situation in the country, and this could be a starting point.
Great. So unfortunately, we are out of time for this panel, but please join me in thanking our speakers.